Hi there. So this is primarily for my mechanics class who I teach M1 to, but anyone else is welcome to watch as well, see how long you last. So if you're watching live, any of the students, my apologies for the late start, but there were a few technical issues. If you're watching later, don't worry about it. So we're going to have a look at some M1 and we're going to start with kinematics. So I'm just going to switch over to share my screen and then we'll get cracking with some mathematics. Okay, so we're looking at the Edexcel spec, which is the one that we're doing. If you're doing it as well and watching, that's great. And we're going to look at the first topics. This is the first episode in what will be several, 6, I suppose, that's going to look at the different topics, getting ready for the exam in the summer. So we're going to look at our Seaver equations, and then we're going to use those for horizontal and vertical motion. And then finally, we're going to have a look at some velocity time graphs, or graphs, as I should have said, but I've spent too long in the south. Right, let's get cracking. So first of all, the Seaver equations. In terms of the Seaver equations, there are several that you need to know, and I'm going to also share a few extras that maybe don't always get shared. Here we go. So rather than derive them, which I would do in class, we're just going to get straight to it because this is meant to be a revision process. So first of all, we've got that we've got our suvat. Just for clarification, S is displacement, U is the initial velocity at the start of the process, V is the final velocity, A is the acceleration. Within M1 for kinematics, acceleration is always going to be a constant. And then finally, T is time. And the way that they relate to each other is that you've got one of your Seaver equations is that the final velocity is equal to the initial velocity plus the acceleration multiplied by the time. Then we've also got, if you rearrange that one, the acceleration is the change in velocity divided by time, but you knew that obviously. Moving on, we've got v squared equals u squared plus 2as. Probably worth actually pausing it and trying to get them out yourself just to practice and see if you were right. You can also rearrange this one. So u squared equals v squared minus 2as. Then we've got our distance equals displacement, equals ut plus a half at squared. Conversely, you can put v in there and make it a minus at squared, half at squared. And finally, if you average out the velocities and multiply it by the time, you'll get the displacement as well. So this is the fundamentals of M1 for kinematics. You need to, first of all, understand the variables you're working with, and that's why we often refer to them as suvat, little way to remember the different variables. And then these are the equations that you can use. The formula sheet for M1 looks like this, with nothing on it. So you don't get any formulae for M1. It's all upon you to learn them and remember them. So a little process of writing these down, turning a sheet over, trying to write them out again is always a good little preparation for the exam. So those are our equations. And what we're going to do now is look at a horizontal motion, vertical motion, and see how we can utilize them to solve a few problems that will crop up in your exam. So the first kind of problems you'll experience are horizontal motion. So generally speaking, you'll have something happening between 2 points, let's call them A and B, and you'll be given some information. And the way that you want to approach it is to always, between A and B, list your variables. So if there's a distance, write it out. If there's a velocities, write them out. And if there's accelerations and times, put them in. And what you'll generally find is that you'll have 3 bits of information. One of them you need to find, and one of them that you don't know and you don't need. So, for example, if you had a distance of 100 meters, an initial velocity of 2 meters per second, you were asked to find v, you didn't know the acceleration, but you were told that it took 10 seconds, then you've got the information you need to solve it. So you'll see we've got S, U, V, and T involved in the question. So you want to pause it. If you're not watching live, you can pause it and see if you remember which equation we'd use. So we're going to be using this one because it involves all the variables we need. So we can substitute in the values we've got. And then we can rearrange it and solve it. So first of all, I'm going to divide by 10. Then I'm going to times by 2. And then I'm going to take away 2. I can work that out. So list your variables, pick your equation. Here's an exam question taken from an Edexcel paper. And we've got our lorry moving along a straight horizontal road with a constant acceleration. It's never going to be anything other than a constant acceleration for M1. So this is the problem we've got to solve. You've got the first part where you have to find U. Note that's 3 marks and the second part is 6. That would imply to me, for 6 marks, that you're not just going to get away with one calculation. You're probably going to need to find one variable in order to find the time. So just use that as a bit of a guide when you see the questions as to how much you might expect to do. Okay, so let's have a little read through. A lorry is moving along a straight horizontal road with a constant acceleration. The lorry passes a point A with speed U. Apparently it's got to be less than 34. And 10 seconds later, it passes point B with a speed of 34. So let's have a think about AB. Suvat. The distance, the initial velocity, the final velocity, we don't seem to know that. Oh no, I tell a lie, we do. It's the acceleration that's not mentioned. And then the time taken is 10 seconds. So S, U, V, and T involved in the question at the moment. A is not. And I just taken to putting the letter for the one I want to find and putting a question mark for the one I don't know. Which equation is it? Well done. There we go. So we're going to be putting our information into this. So we've got 240 equals U plus 34 over 2 multiplied by 10. If we divide by 10 times by 2 and then take away 34. There we go, U equals 14, which is less than 34, so we're okay. So that's part A. Have a look at part B now. Okay. As I said, 6 marks suggests we're going to do a bit more, have to do a bit more. We want to find the time taken for the lorry to move from A to the midpoint of AB. So I'm going to call the midpoint M, and therefore I'm looking at AM. Same process. What are the variables that I know? What are the ones I need to find? So the distance, well, as it's the midpoint, we can confidently say that the distance is going to be 120 meters. The velocity at A at the start, we've worked out in the previous part, so that's 14. If for whatever reason you're in a question where you can't work out the answer to A, but you know that you need it for B, if you don't have an answer, you can just say, I am going to use U as this, and pick a number and work it through. And you can pick up a few method marks, even if you didn't get any kind of an answer for a previous part. Doesn't happen a lot, but just to bear that in mind. V, now this is the final velocity, meaning the velocity at M. Now, we don't know what that is. We could either work it out or we could leave it. It's not the one we're asked to find, so for the moment, I'm going to give it a question mark. The acceleration is also a question mark because we weren't given that. We haven't worked it out. And then the time taken is what we're trying to find. Don't fall into the trap of thinking that the time taken will be 5 seconds to get to the midpoint. Because it's accelerating, it will do the second half of AB quicker than the first half. So the problem we've got is we don't have enough information. We need to have either V or A. So what I can do is go back to this bit and remember the acceleration is constant. So if I work out the acceleration from A to B, I've got the acceleration for the whole lot. So I'm going to need to go back and do and find A. So for that, I'm going to use the information I had for AB. So this time I want to find A. I know my initial velocity, I know my distance, and I know my time for this one. And I also know the final velocity. So we've got a fair old choice of different ones. What I tend to do, if you could choose any equation to work with, I'm going to choose one that's relatively easy to handle. So I'm going to choose V equals U plus AT, which means we've got final velocity equals the initial velocity plus 10 lots of A. Subtract 14 from both sides and divide by 10. So our acceleration is 2 meters per second, which means every second it goes 2 meters per second faster. So what we can do now, just get my eraser. Oh, pardon me. We can get rid of that, and we can now know what it is. Okie dokie. So now we've got S, U, A, and T involved in the question. So that means I'm going to pick. Hopefully you got it right. There's my equation, S equals UT plus a half AT squared. So our distance is 120, sorry, our displacement. We've got 14T plus a half times 2, so that's just 1. So that just comes out as T squared. Now this is the mindset for A level, where you go, yippee, it's a quadratic. And if you rearrange it just so it is all on one side, equal to 0. And then you'll notice that it seems determined to select those. Hopefully you can bear with that. So T squared plus 14T minus 120. It does factorize. So we're going to put a T there, a T there. And we need two numbers that will multiply to give negative 120 and add to give 14. And there we go. So we end up with two possible answers. T plus 20 could be equal to 0 because these two things are being multiplied together to give 0. Or T minus 6 could be 0. So we've got a time of 6 seconds or a time of negative 20 seconds. And hopefully it won't take you long to realize that there's only one viable answer for that, and you're not going to have it 20 seconds in the past. So t equals 6 is our answer. If you do these questions well, you get into a good habit of listing your variables, learning your equations so you know which ones to, and then efficient substitution and solving equations. If any of those things seem like a problem, like solving equations, rearranging equations, then go and practice it, and practice it, and practice it. All right, so that's a horizontal motion example. Now we're going to go on to vertical motion. So once again, I've got a question here that we're going to work through. So a particle P is projected vertically upwards from point A with a speed of u meters per second. The point A is 17.5 meters above the horizontal ground. Sometimes it's worth a sketch. So there's our horizontal ground. There's a nice bit of ground sketching for the potential engineers amongst you. And we've got the point where it's projected from, A, which is 17.5 meters above that. The key for vertical motion questions is to decide whether your positive is going to be up or down and stick with it. It doesn't matter which way around you do it, it'll all work itself out. So if we say for this one that down is positive, and we're going to go with that the whole way through. So the particle point moves freely under gravity. For M1, it's 9.8. The acceleration due to gravity, if you do physics, I think it's 9.81. So it reaches the ground with a speed of 28 meters per second. Show that the initial velocity is 21. Now, actually, what I'm going to do here is it says initial velocity is 21. U is upwards, and it's giving it as positive. So what I'm going to do is I'm going to change. I'm going to stick with the information they've given me. So let's get my eraser. And we're going to switch it around. So U is 21, it's telling us, and we're going to show that. And this means that I'm going to have up as positive. Okay, so we've now going to deal with going from A to the ground. So what is that distance? Well, if up is positive and it's going down by 17.5, our distance is minus 17.5. U is what we're trying to find. Don't just put 21 in and show that it works. You've got to find that it's 21. The final velocity is 28, but that is also in a downwards direction, so it's got to be minus. The acceleration is down, and the time, well, we don't rightly know. So we've got S, U, V, and A. Should be learning your equations by now and realize that we've got V squared equals U squared plus 2AS. So we're going to have to square minus 28, and that is equal to U squared plus 2 times minus 9.8 times minus 17.5. Okay, now this is the bit that my M1 class have been waiting for, and this is a homage to the great Mr. File. There we go. Calculator cam. Right, let's put all the relevant information in. So I'll just do a quick bit of rearranging, and if I take everything else away from this side, minus 28 squared, and then minus 2 times minus 9.8 times minus 17.5, and that'll be all equal to U squared. Note, I've put that in brackets so I can keep it the same as I'm taking it away. It could get complicated with the negatives. So off we go. So that gives me 441. So if I square root that, plus or minus 21. And as we know, it's going up. So it's going to be 21. Okay. Next part, at time t seconds after projection, P is 19 meters above A. Find the possible values of T. So what we're going to need to do now is take this little lot and start over. S, remember our positive is up and this is 19 above A, so our distance now is 19. U is 21. V, we're not quite sure. A is minus 9.8 because our positive is up. And T is what we're trying to find. So we've got S, U, A, and T. So once again, if you aren't watching this live, then pause it and see if you can remember which form you need to use without looking at them. There's a little clue to which formula it is because it says possible values of T. That only happens, possible values, when you've got this equation here because it's got a T and a T squared. Possible values implying you probably have to solve a quadratic. So let's put the information in and see how it comes out. 19, 21T, and then a half times minus 9.8, so minus 4.9T squared. What I'd like to do is just make it a positive quadratic. So if I add that onto both sides, take 21T away, and we've got that. So in terms of possible values of T, now you can boldly try and factorize it, but to be honest, it's probably easier just to use the quadratic formula. So we've got A is 4.9, B is negative 21, and C is 19. So in order to find T, we need to do negative B plus or minus the square root of B squared minus 4 times A times C. Mathematicians have it here, put a little dot for multiply. If you're not familiar with it, that's what it's there for. And if you get to degree level, you might see that happening. And all over 2A, so that'd be 9.8. Calculator cam. All right. In my fraction 21, I'm going to start with plus the square root of, I know it doesn't matter, but you know, good habit, eh? Minus 4 times negative, times 4.9 times, why am I so intent on putting a negative in? Times 19. There you go. And that's all over 9.8 8. All right, so we have got t equals 2.988. Or, for this I can just go back. There we go, and make it minus. 1.298. Worth thinking about why there are two answers and what that means. If you figured that out already, great. If you're not, just pause it, have a think about why are there 2 times when it's at 19 meters. And hopefully you've discovered that obviously it will go up and then come back down through 90 meters. So it goes higher than that. Okay, so that's part B. Part C. The ground is soft, and after P reaches the ground, P sinks vertically downwards into the ground before coming to rest. The mass of P is 4 kilograms, and the ground is assumed to exert a constant resistive force of magnitude 5,000 newtons on P. Find the vertical distance that P sinks into the ground before coming to rest. You can probably tell that we're skipping away from kinematics a bit, but for my class, I know that we have done this very recently, so you should be more than capable of having a go. The fact that we're talking about forces, we want it to come to rest, should lead you to a bit of dynamics, a bit of F equals ma. So we've got a resistive force of 5,000 newtons. From the ground. You've got P is 4 kilograms, so you've got 4G. So let's have a look at how that works out. So we've got 4G down minus 5,000 up should equal 4 times A. Four times 9.8 minus 5,000, and then divide that by 4. So we've got a deceleration or a negative acceleration at 6,201 over 5. And now what we can do is use that to say, set up our things. So from the point it strikes the ground to when it stops, I'm going to call it PG. SUVAT. So we want to find the distance, the vertical distance that it sinks into the ground. The initial velocity, remember it said it reaches the ground with a speed of 28. So we've got 28 down. You'll notice we seem to be taking down as positive now. And that's brought with the fact with how I set up my equation here. I did 4G as positive, so that's down. The final velocity, well, I want it to come to rest, so that should be 0. And our acceleration is that. And we're not too concerned about the time. So SUVA, which means we're going to be using V squared equals U squared plus 2AS. v is 0, u is 28, and we've got 2 times minus 6201 over 5 times s. Right, so if I take away my 28 squared from both sides and then divide by 2 times all of that, I can work out what my s will be. So that's 784. I'm going to divide that by, so let me just, you know what I'd probably do? I'd probably do 12402 over 5. And remember to make sure it's a negative. So it appears it goes sorry, should have made that negative. So it will come out as a positive 316. So 0.316 meters, 31.6 centimeters into the ground. Good question to give an example. It's worth trying to find one of your own to do like this because there's a lot to it. So same process though. Seaver variables, but just remember positive direction, which is it going to be, and stick with it. All right, we're now into the home straight, pardon the kinematics reference, and then velocity time graphs. So what you're required to do is take situations of motion and plot a velocity time graph. Now, you've got to remember the acceleration is constant. So what that means is that if the velocity over a certain time changes, it's going to be a constant acceleration. Now, on a velocity time graph, if you look at this situation here, so something, you could say a car has accelerated up to 5 meters per second. And it might have taken it 2 seconds. So the acceleration in this time is the change in speed. Remember this one? So the acceleration is the change in the velocity over time. So 5 minus 0 over 2. So 2.5 meters per second squared. So that's what happens if you've got something accelerating. If alternatively you've got something going at a constant speed, then you'll get a section like this where it's absolutely flat, no acceleration because the gradient is 0. And let's say, for example, that traveled along merrily for another 5 seconds, taking us to 7. Careful how you label your axes with these ones. And then at that point, then it decelerates, could be a really slowly decelerating or slam the brakes on and decelerate really, really quickly. So if we go for something like that, where it just gives itself 1 split second. So that's meant to be an 8, by the way. And then it goes back down. So for this section here, we've got an acceleration of v minus u over t. So, well, its final velocity is 0. Its initial velocity was 5, because we can see, there you go, it was 5, and that's all over 1 second. So we've got -5 meters per second. So it's slowing down at that rate. So that's how you find the acceleration on the velocity time graph. Now, what we'd want to know now is the distance that it's covered. So in order to find the distance on this is represented by the area. And if you recall earlier, we had this equation, S equals U plus V over 2 times T. So if you look at that for each section, let's call it section A, we've got S equals, well, U is 0, that's 5 over 2 times by 2. So the distance covered for that one is 5. You'll also notice that the area of this triangle here is 5. Base is 2, height is 5, 2 times 5, and then halve it. For this middle section here, we've got initial velocity is 5, final velocity is 5, half of that is going to be 5, and then the time is 5. So we end up with 10 divided by 2 is 5 times 5, 25 meters covered in that part, 5 meters covered in that part. And then finally, if you look at the third section, C, we've got initial 5, final 0, all over 2, and then times that by the time, which was 1. So we end up with a distance of 2.5 meters covered. So the total distance covered was 32.5, because the area is the distance covered. All right, so let's put that into practice within a question. So here we go, got an exam question here. You're given the velocity time graph. In this case, you're not always. Sometimes you're required to draw it from the information. If you can't find enough of those questions where you go to draw it, try and find some questions and see if you can cover up the graph. Because if we just look at this bit, the velocity time graph, so it's 2 stations which are 1.5 kilometers apart. The train leaves the first station accelerating uniformly from rest for 300 meters until it reaches a speed of 30 meters per second. So there we go. We add a bit of information ourselves. That's a bit of time we're looking for. And this first section here, I call it A, 300 meters. That means the area is 300. So without too much bother, you can probably work out what the time is. If we carry on reading through the information though first, the train then maintains this speed for t seconds before decelerating uniformly at 1.5 meters per second. So we've got the deceleration of this part, which means that that is the gradient of that line. And remember, that. So we know that the final velocity is going to be 0. We know that that's the initial velocity was 30. And we got t, and that's all equal to minus 1.25. Anyway, I'm getting ahead of myself. All right, the first question for part A asks us to find the acceleration of p during the first 300 meters of its journey. So we've got this section here is our first 300 meters. So we've got a triangle where the base is the, we're not sure about. The height is 30. and divide that by 2 because it's a triangle, and that should give us 300. So times by 2 is 600, divide by 30. It would appear it takes it somewhere in the region of 20 seconds. So that means that the acceleration is going to be the change in velocity, well, that's 30 divided by the time, and there's our acceleration. So that's all based on the triangle should be equal to the distance. So base times height halved. Okay, I hope you're sticking with it. Or maybe you've watched it in several goes. Right, find the value of t. So this second... My apologies for that. So the whole bit here, the whole thing, you'll see this bit 1.5 kilometers apart. So the area under the whole lot is 1.5 kilometers. Now we know that A is 300. We're looking for the time for B, and we could do know the distance for C. You remember earlier, I sort of here started to look at, well, we know the acceleration, we know the initial and the final velocity of this section, but we don't know the time. So let's just work that out. So if I rearrange that and just quickly plug that in. So it tells us it's going to be 24. So we've got 24 seconds. Earlier we found out that bit was 20. So we can now find the distance for C as well. So the distance for C is going to be the base times the height halved. So 30 times 24, 720, not be cocky. Good. So we've got a distance of 360. So altogether, A plus B plus C, the three sections, should all come to 1.5 kilometers or 1,500 meters. We already know that A is 300. We know that we're looking for B, and C is 360. So you've got 660, which should leave us with 840. So that's our distance for B, and that section there where we've got T, that's 30, and our area is 840. So 840 divided by 30, 28. So T equals 28 seconds. Okay. almost there. The second train queue completes the same journey in the same total time. And just worth pointing out, what's our total time? Well, we've got 20, 28, 24. So 60, 72. The train leaves the first station, accelerating uniformly from rest until it reaches a speed of v, and then immediately decelerates uniformly to come to rest at the next station. Sketch on the diagram above the velocity time graph, which represents the journey of train Q. So you don't have to get it 100% accurate, but bearing in mind that it completes the same journey in the same time. So it's going to have to start and end at the same point. And it's going to have the same area. So if you think about that, it accelerates and then immediately decelerates. It's going to be a triangle. So it's going to look something like that. And all you have to make sure you do is indicate where V is. Find the value of V. So what do we know about this? We know that it covers the same distance in the same time. So we've got a height of our triangle of V. We know that that is 72. 72V over 2 will equal the same distance. And generous that is for 6 marks. But we've got to bear in mind is some of the work's kind of been done on along the way. So we've got this 840 meters and a time of 28. And I've added those 3 times together. So you did a bit of work for it before then. Okay, quick recap and then we're done. Seaver equations, learn them. A good tactic for that is write them out. Turn a paper over, try and write them all down. Always list your variables and then put your equation in. List your variables, put your equation in. Try and pay attention to the number of marks, gives you an indication of how much you expect to do. And then for vertical motion, remember positive direction and pick it and stick with it. And don't be afraid if they start asking you about some dynamic stuff along the way. And then finally, velocity time graphs. The distance is the area underneath and the gradient is the acceleration. But if you know your Seaver equations, it can save you a lot of bother because they work in the same way. Right. I shall wish you a good evening or whenever you're watching this and hope that that was useful. Hopefully I'll be able to send episode 2 out where we'll look at some statics in the next week.